Okay, so let's look at what we talked about in class yesterday and today, doing a little work with exponents. If you remember, just kind of a recap, we talked about if I have exponents that are the same bases, right? And I'm going to multiply these two, okay? Remember, we talked about we're going to keep the base, then we're going to add the exponents. So my answer is x to the 6th power. So just kind of help you remember, if we were to do this, it looks kind of funny because it says we're multiplying, but we actually added. But if you'll look over here, if I write x to the 2nd power, if I was to spread that out, that means x times x. Then we have x to the 4th power, which is x times x times x times x. Well, if I start counting, 1, 2, 3, 4, 5, 6. So I have 6 x's, so x to the 6th power. So all you're doing is, if it's the same base, then you're just going to add your exponents. Okay, let's look at another one. What if I was to change this a little bit and I was to add a number as a base instead of a variable? What if I have something like 3 to the 3rd power times 3 to the 2nd power? Well, it's the same concept. What I actually have here is 3 times 3 times 3 times 3 times 3. So these are these 3, these are these 3. Okay? So if I was to add these together, my base is 3, and I have 1, 2, 3, 4, 5. So the shortcut way is to just say, hey, my base is 3, I'm going to keep it, and I'm going to add the two exponents. So it's 3 to the 5th power. All right, so if we look at that, we can say, now I can actually evaluate a little bit further, but you can use your calculator for that. But I wanted you to get the concept of just keeping the base, adding your exponents. Okay, so let's go another step. Let's try one more. What if I have 4 to the 2nd power times 4 to the 5th power? Well, this time I'm not going to spread it out. We're just going to use our rule. Here's my base. It's just the same base. I'm going to keep the base, and I'm going to add my exponents. So my answer comes out to be 4 to the 7th power. Okay, let's put a coefficient with this one. Let's kind of add something to this. What if I come back with this one? 2x squared times 4x to the 6th power. Well, now I've got a little bit of different. X is my base, but now I have a number in front. Remember, we call that a coefficient. Remember, if we're doing this, we're going to multiply the coefficient, and we're going to add the same base exponents we're multiplying. So 2 times 4 gives me 8. Then I have x, 2 plus 6 gives me 8x to the 8th power. That's my final answer. Okay, I can't go any further because I have no idea what x is. Nobody told me, so I'm finished with that one. All right, let's do something we haven't done right quick. Let's check this. What if I had a negative coefficient? X, let's do something besides x. What if I say a to the 3rd, b to the 8th, times 3a to the 8th, b to the 3rd? Same concept. Now I have a coefficient. Same thing. We're going to multiply here. We're going to multiply. We're going to add. And we're going to add. Okay? So negative 6 times 3 is a negative 18. My base of a and a base of a. So I have 3 plus 8. Then I have a base of b. I have 8 plus 3. So to finish this out, we have negative 18. A, 3 plus 8 is 11. B, 8 plus 3 is 11. So there's your final answer. Okay, most of us were doing pretty good with these. Let's try one more. Let's see what we have. What if I was to give something like this? What if I was to say 4 m to the 3rd, n to the 12th, times 8m, and that's all I want to do. Okay, same concept. We're going to multiply, and and we're going to add, and oops, there's nothing to add that one to, so we're not going to do anything to it but bring it over. Alright, so first off, 4 times 8 is 32. Now, I've got an M and I've got an M. I've got a 3, but remember I have a ghost back. If I don't see this exponent, I've got to give it an exponent of 1. So 3 plus 1, n to the 12th power. Just bring this n to the 12th over here because there's nothing on this side to add to it. So my final answer is 32 m to the 4th n to the 12th power. Okay, so that kind of covers that left side of our graphic organizer. Let's kind of go to the middle. What if I have, when we call this piggybacking, remember it's really called power to a power, but remember we gave it the shortcut name of piggyback because you have an exponent inside and outside the parentheses. So let's go really quick. Let's do a simple one. What if I have x squared to the 3rd power? Remember, piggyback means we're going to multiply the exponents. Okay, so all we're going to do, I have an exponent inside, exponent outside, draw our rainbow. So now we have x to the 2nd times 3, which gives me x to the 6th power. So the difference here is this one is on the outside. Before we would have added these two, but since it's on the outside, power raised to a power, we have to multiply it. Let's drop down. Let's do another. What if I was to go? Let's add a coefficient. What if I was to go 2 square a square raised to the 4th power? Alright, so we can actually work out now. We have the 2 has a exponent, and the a has an exponent. So draw 2 rainbows. So we have 2 to the 2nd times 4, a to the 2nd times 4. And then we can solve it out. So 2 to the 8th power, a to the 8th power. Now we can actually go a little bit further, but I don't happen to have my calculator handy right now, but we can multiply this. We can put this in our calculator, 2 to the 8th power, and we could have solved it out a little bit further. Okay, so that's basically just the concept is getting the multiplication of the exponents down. Let's try one more. What if I go this one? What if I go 6a square? So now I'm looking inside. Well, I have 2 bases, but I have 2 ghosts as well. So we have to add the ones. Draw your double rainbows. So I have 6, 1 times 2, a 1 times 2. So I have 6, 1 times 2 is 2, a 1 times 2 is 2. Now this one, I can do this one in my head really. So this means, remember, 6 to the 2nd power means 6 times 6, not 6 times 2. So the answer is 36a squared. So just all you're doing is carrying out the order of operations, kind of like the please excuse my dear Aunt Sally. All right, let's try a combination really quick. What if I have something like this? What if I take 3x to the 2nd, y to the 4th, and I raise that to the 3rd power? Okay. Same concept we did before, but now we're going to add a little bit to it. We're going to go with 4x to the 3rd, y to the 9th, raised to the 9th power. So we got to do a little work here. First off, we're going to work. Remember, we're going to get rid of this first. We're going to do the piggyback first, and then we're going to do spread out. But first, I'm looking here. I need a ghost here, and I've got a ghost here, right? So now everything has an exponent. So let's draw our triple rainbows. 1, 2, 3. Let's do the left side first. So 3, 1 times 3, x 2 times 3, and y 4 times 3. Alright, so that's the left side. Let's go ahead and do the right side. So draw your rainbows. 1, 2, 3. Sorry, that line should be pointing closer to there. Alright, so now I have 4, 1 times 9, x 3 times 9, and y 9 times 9. Alright, so let's finish this side out over here. So 1 times 3 is 3 to the 3rd power. X 2 times 3 is 6. Y 4 times 3 is 12. Okay, then I'm going to multiply this. 4, 1 times 9 is 9. x, 3 times 9 is 27, and y, 9 times 9 is 81. Alright, so we can look at here, we can work this out a little bit. Remember, we can't multiply these two bases, they are different. So I know 3 times 3 is, 3 to the third power is 27, x to the 6th, y to the 12th. Okay, in just a minute I'm going to get this one for you. Let's figure out, so we'll go first here, x to the 27th, y to the 81st, and if you give me just 1 second, I'm going to get a calculator. Hold on. Okay, I do apologize. I should have had my calculator ready before I started. So if I do 4 to the 9th power, that gives me 262,144. That's a pretty big number. Okay, so that's why I was talking about, sometimes you may not have to work it all the way out, but this time we will. So we'll go 262,144, x to the 27th, y to the 81st. Whew, that's a big number. But now we got to finish it out. We have a little bit of work left to do. So here I know I have a coefficient and a coefficient. So we're going to take this big number and we're going to multiply it times 27, and it's going to get even bigger. So I have 7077888. So 1, 2, 3, 1, 2, so I have 7,077,888. X, here's the x, here's an x. 6 plus 27 is x to the 33rd power. Y and a y, 12 and 81 is 93. Ooh, that was a very big number. You guys deserve a hand if you got that one right. That's an awesome job. Okay? Alright, I want to do one with you really quick. I want you to take a second. I want you to pause this one. When I tell you to pause it, I want you to try to solve it by yourself. Let's do a little one that's a little more simple than that one. Let's go back to this. What if I have something like 3a to the 3rd, okay, to the 2nd power, times 2a to the 4th to the 2nd power. Okay, what I want you to do right here is I want you to pause the video just for a second. I want to see if you can solve it on your own. I'm going to keep going. When you figure out your answer, you start it back up. Okay, alright, welcome back. So we have power here, power here. So 3, I'm going to do the shortcut. 1 times 2 is 2. Let me fix that. So that's 3. 1 times 2 is 2. 3 times 2 is 6. Okay, I have a ghost here, so draw a double rainbow. 2, 1 times 2 is 2. 4 times 2 is 8. So these are a little more manageable numbers than that last one we just had. Okay, so 3 squared is 9, a to the 6th power. 2 times 2 is 4, a to the 8th power. Here's my coefficients. They're 9 and 4, so 9 times 4 is 36. 6 plus 8 is 14. So your final answer is 36, a to the 14th power. And again, like I said earlier, we can't go any further because we don't know what a is. So really we're done for this problem. So this is my final answer. Okay, so that's a good job. So I hope you got that same answer, and we'll work on some more of these tomorrow. We're actually going to start with working on the division part of exponents. So be ready for that tomorrow. Thank you. Have a good evening.